I have this really old Craftsman 7.5-inch circular saw. It does not work anymore. If you pull the trigger and it's plugged in, it just does nothing. Sounds kind of clunky. I don't know if that's how these switches are supposed to sound, but I think the first thing we need to do is take this panel off and test the switch to see if it's any good or not. I have no idea how old this saw is. I tried to find some information online and I just couldn't come up with anything. I don't know if that 3-58 is a date code. Maybe it's March of 1958. I don't know. I did find this in the box. So originally it was $64.95, and it does say Sears, Roebuck and Company, so I know it's quite old. Pulling these two screws out, I can just pop this off, maybe. It probably hasn't been apart in a very long time. And we can see it's just a pretty simple switch mechanism. So if I were to take a guess here, it looks like they are turning on and off both the common and the hot. And it looks like we just have a couple of butt connectors here. My guess is two wires, the common and the hot go straight out to the plug, and the other two wires are probably going to a set of brushes. So seems pretty simple, but what we want to do is take a meter and we're going to test for continuity between here and here and here and here, and that'll tell us if the switch is indeed working or not. If we get some continuity on that, we might want to also check to see if we're getting power through the cord. You never know, it could be something simple, maybe just a bad cord. But you want to start off simple and then kind of work yourself into the more complicated things. Now, I thought about taking the back off of this switch, but quite honestly, it doesn't want to come apart. I can unscrew this little guy here, and you would thought that that would release the back, but it definitely doesn't want to come off. And then there's some type of melted glob here. Maybe they do this after they put it together. If you look at the top of the switch, you can see there's the place for where that screw just came out, and then there's one on this side, and it looks more like a rivet. So I'm thinking that we'll just take the multimeter and try to shove its leads in each end and then click it on and off and see if we get continuity. So as difficult as this is, we're going to kind of two-hand it. And you can see the meter has open circuit, and when I click it, I now have continuity on that side. Let's do the other side. And open. And we're closed. So I'm going to say the switch is working. Let's test the other side one more time. I don't think I really had a good bite with the leads there. Oh, closed, open. So I'm going to assume the switch is good. At least we know it's getting continuity without a load. Doesn't mean that when we get a load on it, it isn't doing something funny inside, but I'm going to take a bet that the switch is good. Now what we want to do is test power, and it probably would have been the smartest thing to check that first. But plugging the cord in, we're going to try not to electrocute ourselves and see if we have actual power coming into the switch. We might not. You never know. It could be something simple like that. All right, so I have the saw plugged in. I'm going to very carefully kind of push these leads a little further inside. And if you look at the multimeter, we have 123 volts AC. So we are getting power coming into the switch. So the switch and the power cord is probably not the problem here. We need to dig a little bit deeper. Luckily, these saws are pretty simple. The only other thing left is these wires go to a set of brushes, I assume. When we tear this saw apart, we will confirm that, and we'll see how those brushes look. Unfortunately, the brushes are not serviceable from the outside like many saws. You really have to tear it apart to even look at the brushes. Now that I've flipped the saw over to take a little better look, I understand how it's put together. You have to take this plate off the bottom to be able to get to the rest of the screws. But one thing I want to point out is this screw is loose, and I did not loosen that screw. This screw is loose. I also did not loosen that. We're missing one. So that tells me somebody's had this saw apart, and we might be in for a real treat, because if somebody else couldn't have fixed it, then obviously it's something pretty complicated. But you never know. Let's take a look. We'll take the bottom off and we'll look inside. It took a little more than I thought to get it apart to this stage, but I did find maybe another point of failure. We have those wires coming off the switch, go to kind of a contact plate on top. It's kind of a plug, if you can see right there. And the receiving part is down here. So if that were to fail, it obviously wouldn't work. And then these wires go directly to the brushes. So at this point, we could kind of play a game. We could add power here and here and see if it fires up and spins. I think that sounds kind of fun. Let's go ahead and do that. It seems kind of daring and dangerous. All right, now what we have here is a suicide cord, and we have power to it. So you definitely don't want to do this at home, but it's okay. We're being safe about it. We have safety glasses, so we probably will not electrocute ourselves. So I'm just going to reach down in here on each side and just give it a little bump. And we have nothing. Nothing, nothing, nothing. So we could pull these off. And see what we got. They look pretty good inside, really. They don't look corroded or anything. But, same thing. Remember, these are live, so don't do this at home. We have nothing. See? Nothing. So now we got to do a little more troubleshooting and see what's going on here. We could give it direct power down here to the brushes, I think maybe. No, because this goes into a winding, and this one, I don't know where it goes. Let's take a look here. It's also going into a winding. All right, now what we have here is a suicide cord, and we have power to it. So you definitely don't want to do this at home, but it's okay. We're being safe about it. We have safety glasses, so we probably will not electrocute ourselves. So I'm just going to reach down in here on each side and just give it a little bump. And we have nothing. Nothing, nothing, nothing. So we could pull these off. And see what we got. They look pretty good inside, really. They don't look corroded or anything. But, same thing. Remember, these are live, so don't do this at home. We have nothing. See? Nothing. So now we got to do a little more troubleshooting and see what's going on here. Alright, next thing we can do is kind of poke around with the brushes a little bit. I do see a problem. Actually, this brush is exceptionally loose and it's not under tension anymore. And there's some melded brush holder part right there. So this one actually may be our entire problem. It should be on a spring of some sort and it won't even pull out. This one, the spring does appear to be working, as you can see. So let's see what's going on here. Are we missing the spring? Or no, the spring's back there. I see the spring. It's just looks like it's blue on the end, so it's gotten very hot, and I have a sneaky suspicion it's probably lost some of its tension. But the other problem is this does not slide back in there very easy like it should. It's got some drag to it, and we've lost some hairs on our wires. So we definitely need a new brush, or we need to do something about this brush. But I think actually the hairs appear to be caught in this plastic. So maybe, this is a thought, maybe the thing got hot and it kind of snagged some of the brushes, and as it was being used, it just kind of ate itself. The plastic melted and this got stuck in, and things just kept getting worse and worse. So let's kind of break it free. Put the spring back down inside. That's got a little bit of spring, not nearly as much tension as this one, but it might be enough to see if we run. Shove this back in here for now. And then the one thing I'm kind of worried about is if I power this up on the table, this might flip them out like that. So I want to find a way to temporarily hold these in, and then we'll take our suicide cable, add power again, and see if she fires up. And if it does, we know we need to do something about this brush holder, and pretty much put it back together, and we should be good to go. And here we go again with the live leads. I do have the brushes kind of zip tied in there so they won't fling out and kill me. And we'll put the safety glasses on so we don't get electrocuted. Now we're safe. And we'll reach down in here and we'll give it some power, and we got nothing. I still think there's probably a problem with this contact. So we're going to tear this apart a little bit, take a better look at it. I just think there's something going on here that we're not seeing. So I've brought you in here a little closer on purpose because I want to show you the brush holder in detail. So there is a metal clip here that's kind of cattywampus because it's melted a little bit. And there's one over here, and I thought that was one piece, like a big U, and went all the way around the back, and maybe the spring shoved against the back of it. But that doesn't appear to be the case. If I take my meter or my lead to my meter here, and I hold it on this side, this little metal clip there that the actual wire coming out of the housing is soldered to, and I take this lead and I hold it over here, nothing shows up on my meter. See how it still says it's open? Now if I touch my leads together, it's closed. I should have continuity all the way to the brush wire, and I do not. So that is a problem. That's probably why this is not running right now. So this brush holder needs replaced. The odds of getting a brush holder like this is probably slim to none. I just don't think it's going to happen. But maybe we can rework the brush holder a little bit and get it working. Worst case scenario, maybe we take a 3D printer and we print a brush holder. But I think for now we're going to kind of do a little jerry rigging here and see if we can't get it to fire so that we know the motor is at least good before we invest time in building a brush holder. Well, I tell you what, this has gone from pretty ghetto to very ghetto. I basically took a couple of brad nails and I just kind of wedged them down in between the bracket. That way the continuity will be carried from this wire through this metal bracket. And then I took another little nail or brad and I wedged it between the holder over here and the casing so that the current will flow back through the brush holder and then back through the brush. Now this is absolutely not going to stay this way. We just want to see if the motor is good because obviously these won't stay, and this is not the correct way to fix this. We either have to find a brush holder or 3D print a brush holder, one or the other. We'll come up with some option or some solution to put this back in service. But right now we just want to test it and make sure that everything else is good before we spend our time and efforts making a brush holder. So now we're going to take our hot wires and see if we can kind of tap start this. Now I expect it's going to have a lot of torque, a nice good spark, but if it spins any at all, we know it's good. And there we go. So we know the motor's good, and now we just need to fix the brush holder, and then we'll have a working saw again. Now, I hate to leave you guys hanging, but I believe there's going to have to be a part 2. I'm going to need to resource either that brush holder on the other side or take a 3D printer and make one. But I will come up with something, and we will do a part 2, and we will get this saw back in service. So please like and subscribe. Take a look at some of my other videos. You might find something entertaining.